I'm very excited. Ladies and gentlemen, offline and online, good evening, everyone. I am Xiaopeng, and welcome to our annual 1024 XPENG Tech Day. Happy to see you all again. Firstly, please let me report to you on what we have been doing since the Tech Day last year. First of all, we mass-produced XNet and truly realized the mass production of XNGP. Second, XNGP is based on high-definition maps, and we have been able to roll it out to 5 cities, including Beijing, Shanghai, Guangzhou, Shenzhen, and Foshan, becoming the first automaking company in China to launch city-assisted driving in these 5 cities. And number 3, XPENG officially launched Full Scenario Voice Assistant 2.0 and Smart Scenario. We don't like to rely on short videos from the internet to claim our leadership in our functions and performance. We prefer to deliver, and we are determined to develop solid technology and implement it. Now today, let me share with you some of the companies and also my own thoughts on the future. Now, we used to hear the saying that software defines cars. But this year, we propose that AI is redefining cars. What is the difference between software and AI? A lot of you might think that AI is part of software. But from another perspective, software actually converts the rules from a human's perspective into software, while AI and oftentimes converts many rules from a machine's perspective into software. So software-defined cars and AI-defined cars will change drastically in the future. Over the past century, hundreds of automaking companies have been emerged worldwide. And if one day AI penetrates 50% of a car's capabilities, then we expect to see AI-defined cars, and a significant amount of car-making companies will become obsolete. When I entered the automaking industry in 2017, I was speaking at a conference in Beijing, and I asked the audience, how many of you often drive new energy vehicles? 1,000 or hundreds of people were in the audience, and less than 1% raised their hands. And recently in Shanghai, I was at a Shanghai Technology and Industry Pioneer Forum. I asked the audience, how many of you have driven city-assisted driving cars in Shanghai? In a venue of hundreds of people, only a few people raised their hands. And it's been 5.5 years since 2017, during which the penetration rate of new energy vehicles in China has gone from about 2% to over 40% in some cities. And in the coming 5 years, I believe that the penetration rate of smart driving will undergo the same kind of dramatic changes as new energy vehicles did. And the next 5 years belong to full autonomous driving and a new era of smart cars. And AI will start to define cars. Now today, we not only want to share XPENG's views on AI, we also would like to share our views on mobility. We've been exploring and deploying everything from four-wheel mobility to low-altitude flight mobility and also robotics. And we firmly position ourselves as explorer and revolutionary of future mobility as our vision. And I'll bring you an important guest, Dr. Li Liyun, today, who's also the builder of our XNGP. He takes the stage for the first time today to share XPENG's technological progress and future vision in full autonomous driving. Please, let's welcome Dr. Li Liyun. Ladies and gentlemen, good evening. I am Li Liyun from XPENG Autonomous Driving. I'm very excited to meet you on the stage of 1024 Tech Day this year. If the first half of the game in smart driving is to open up users' minds or educate the public through simple scenarios such as highway navigation-assisted driving and auto parking, then the second half of the game will be the competition of city smart driving. With the support of previous generations of architects of high-definition maps, we have rolled out smart driving in 5 cities: Beijing, Shanghai, Guangzhou, Shenzhen, and Foshan. And the upcoming challenge of our progress lies in the geographical restrictions and high-definition maps, availability of those maps. In order to break through such limitation, we launched the latest version of XNGP. Now, the biggest feature of the latest version is that it can be used nationwide. So far, our XNGP can cover 73% of the country's road networks that are not covered by high-definition maps. And our city rollout speed is 20 times faster than before, which means that the time we used to roll out one city based on high-definition maps can now support the rollout of 20 cities, and the cost is only 1/10 of the original. Now, during the first half of the game of smart driving, we took the lead in mass-producing city smart driving in 5 cities, including Beijing, Shanghai, etc., which established our leader position in the mass production of smart driving in China. And right now, we went from insight to leadership, and we take the lead in running into the second half of the game. So far, our XNGP capabilities can be deployed nationwide. And as you can see, these 3 videos were actually gathered from different parts of the country, east, north, west, where we conducted XNGP testing. And the software that we're using in the testing will be pushed out to the users via OTA very soon. And we will gradually roll out to more cities so that our users across the country can enjoy city-assisted driving. At the same time, in the 5.35 million kilometers of public roads across the country, there are some country roads and rural roads that we will actually support using real-time validation in shadow mode. And as we have bigger and bigger fleets and the wider the driving coverage, we can expect the greater the available scenarios, and we can actually do function validation and the collection of features and scenario training from the cloud. And we invite all of you to join us in using XNGP to actually enhance our coverage in the country. We not only focus on covering the whole country, we also prioritize great user experience. We have launched our AI valet driver function in order to give our users the best smart driving assisted experience on the most commonly used commuting function. And this function is not limited to cities and is available nationwide. It only needs to be learned once, and the learning process is seamless. In addition, we will continue to iterate and optimize the experience in the cloud so that this function can be available across the country and will be very easy to use. Coming up, we will roll out the function to the majority of our users through recruitment. Now, the above mentioned is our high-end city smart driving strategy. And my team and I will go all out to achieve 2 OKRs, which is whole country coverage and best user experience. And we will try our best to cover every corner of the 5.35 million kilometers of roads across the country to make sure that the user experience is comfortable, safe, and efficient. And we want to achieve both of these goals. Now, the bottom layer of our smart driving capabilities is strong and deep technical support as well as our efficient middle and back-end system. Now, the slide here shows the evolution history of our full scenario smart driving architecture. When we first started doing highway navigation assisted driving and city NGP, relying on high precision maps, we didn't have the support of BEV transformer architecture at the time. We needed high precision maps. It's equipped with various modules such as sensor fusion and positioning. As we shared with you last year, when we first enter the space of city smart driving, the entire code amount increased by 4 times, especially the prediction and planning code, which increased by 66 times. These are all in order to provide our users with a safe and reliable solution. And it's something that we had to do and experience. But we have accumulated enough experience and sufficient data in urban scenes now. Just like we are very diligent students trying to achieve the best result in an exam. And in preparation, we read a lot of books, etc. As an exchange, we are able to gain deeper and deeper understanding that can enhance our efficiency. And that is why we now can enhance our efficiency, supported by our past practice, experience, and technology accumulation. Now, our ultimate smart city driving architecture for all scenario is called XPENG. Because during our practice, we have been able to form a very natural and clear process, just like the human brain, with our technology. And it's very organic, very clear. And the core component of our XPENG is, first of all, our next generation of perception system, which is very powerful. It's called XNet 2.0. It's a perceptual system with the ability to understand space and time. Not only that, we're also about to launch a next generation spatial temporal planning and forecasting system or prediction system based on neural networks, which is XPlanner. And we hope that XPlanner in the car will not only provide driving functions for our users, but a lot more. Now, let me introduce to you our latest generation, XNet 2.0, a powerful perception system. XNet 2.0 is a 3-in-1 architecture. It has our enhanced spatial temporal perception, combining dynamic, static, and occupancy network, which we call the golden backbone. Last year, on the Tech Day, we share XNet 1.0 with all of you. At that time, that version had 2 independent pillars. One was the dynamic BEV and the other was static BEV. Now, in this 3-in-1 version, this is a triple network architecture, which is a lot more powerful. To give you an example, if we considered ground lane lines solely from the perspective of static XNet, it might be difficult to deal with the challenges of occlusion cases. Under the XNet 2.0, this 3-in-1 architecture, we now have this very powerful supplementary occlusion detection capabilities that can naturally handle conditions such as occlusion and unclear lighting. It can also well cope with various complex, special-shaped situations or corner cases during the rollout process. Not only that, we now have stronger horizontal and vertical sensing intensity that has been increased by 200% that help us to identify 11 types more items, including small animals, ground logs, unparked, unattended bicycles, etc. Now, our occupancy network is also very powerful. It's already twice the top level in the industry. With occupancy network, we can now get a very good understanding of road edges, thin pillars, or sparse screening, etc., helping XNGP gain superior bypassing and obstacle avoidance capabilities. Not only that, XNet 2.0 is the first AI large model-enabled perception architecture with spatial temporal understanding. As we deploy XNGP to various cities, it can effectively understand different scenarios, such as which lane can be entered at what time and which direction a certain tidal lane travels at what time, etc. It can understand the distinct traffic elements of different cities, which is a powerful technical guarantee for our efficient rollout. And a lot of you are curious about what we can share with you in terms of regulation and control, in addition to our powerful next-gen sensing or perception system. Now here I would like to share with you a story from the initial deployment of our city NGP. Now in the beginning, we developed various algorithms, including detours, offsets, and a lot more. And our previous generation of decision-making planning architecture encounter different issues. For example, users complained that our algorithms were not smart enough or human-like enough. In our latest X-Planner architecture, we focus on simplifying the complex situations, and we continue to promote model and data-driven evolution. And our architecture has several great features. First of all, X-Planner is a large neural network with long memory and long sequence. It has minute-level planning capabilities. Drivers typically have this kind of experience where during the driving process, we do not observe the other party's behaviors way ahead of time. Now, in the traditional framework, this is called prediction. But in fact, our behavior is organically integrated with the surrounding world. Therefore, our latest X-Planner architecture has the capability of simulation and human-like reasoning or prediction capabilities. But I would also like to add that without our previous hard work in city scenarios or our experience in mass production in Beijing and a lot of other cities, we would not have been able to achieve this generation of X-Planner. Just like the Chinese saying goes, you can't reach 1,000 miles without taking small steps. So definitely this experience in the past and optimization of the rules in the past was a great foundation for us. The evolution of our technology definitely brings about enhanced capabilities, simplification of our software and hardware architecture, and also cost reduction. In 2024, our XNGP with less reliance on HD maps will cover all of China. Not only that, we will also go global. We will use our XNet perception capabilities of large models to roll out the entire scenario. With our full scenario smart assisted driving, everyone will automatically pass through highways and city toll stations without supervision. And you can also pass automatically at the intersection of residential areas or urban roads. More importantly, technology can introduce a lot more benefits and cost reduction. And this powerful perception capability in XNet achieve cost reduction on the latest MPV X9 model developed by ourselves, removing the two forward-angle radars, and at the same time maintaining the super powerful XNGP capabilities. Now, what ensures our smart driving capability is our strong mid and back-end capabilities. The efficiency of data processing is the key. As you can see, the entire data processing closed-loop function is here. Last year, we were able to solve around 1,000 various corner cases every year. This year, we have worked tirelessly to improve the efficiency of data collection, model training, model deployment, including simulation. We have increased the efficiency by 150%. This year, we can handle more than 2,500 corner cases. Not only that, for those of you who have tested our city NGP, you would know that for some simple map issues or problems that can be easily solved by cloud strategies, we can actually solve these issues within 2 hours, making the user experience better and better. So with the support of such architecture capabilities and such high efficiency, the number of passive takeovers in city roads has been reduced by 38% due to our relentless effort over the past year. I would also like to share an interesting point here. Last year, we showed you a short video of a burning truck uploaded by our users. Now, last year, we used simulated data. And right now, as we speak, we have the ability to directly use AI to generate data and extreme scenarios. And we can also organically integrate these data into massive training. And through full-stack closed-loop capabilities, we can ensure safe and reasonable responses to these extreme scenarios from end to end. Behind the powerful capabilities of the mid and back end is our full-stack simulation capability. Every key code change and every model update were not done separately through simulation, nor a simulation of several separate modules. Instead, we combined all of the modules and we ran them together. Last year, we ran 50 million kilometers of simulation. And as of 2023, our simulation mileage has reached 122 million kilometers. And there are 12,500 core simulation scenarios with which we guarantee no fallbacks. And there are 36,000 special scenarios. And they are more complicated. For example, someone cutting your lane, or when you have to conduct more than one extreme lane change in a short amount of time. So under these scenarios, we will comprehensively evaluate the performance of the entire system. And the ultimate goal is that through full-stack simulation capability, we can deliver safer, more efficient, and more humanistic city navigation-assisted driving capability. And we have enhanced our overall protection level and efficiency by 4 times, which means that 80% of the issues can be solved in the simulation stage. Now, we have a larger number of real car verification or validation in reality, but more importantly, they are used to polish the experience and also explore extreme cases that are not yet discovered in the library or generated through our system. So regardless of the various skills in the car or our core middle and back office capability, we are proud to say that we are really leading with solid technology. We do not make empty promises, we deliver. And the goal is very simple, which is to provide seamless and excellent user experience so that XNGP can be used nationwide and they are easy to use throughout different city roads. Now let's ask Xiaopeng back to the stage to share with you the progress of XNGP, and every word that he's going to say will become our OKR. Thank you all. Thank you so much, Li Yun. Li Yun and his team have been working really hard recently. They've traveled to over 50 cities to facilitate the rollout of XNGP. And I actually went to one of these cities last week, and I tested the new XNGP on the streets for about 40 minutes. Honestly speaking, it felt basically the same as in Guangzhou. So let's give a round of applause to Dr. Li and his team. Now, here I would like to say that I noticed something interesting. Since we launched our solution with less map reliance last year, many people in the industry started to think about this too. And this year, we're going to launch a new solution with less reliance on radar. And it will first be seen on the X9. And I believe that this will also become a future technological trend too. Now, let me share with you the specific time plan for XNGP rollout. Now, 1 month from now, by the end of next month, we are going to roll it out to 25 cities, including Hangzhou, Wuxi, Ningbo, etc. So if you are in one of those cities, please be prepared for the OTA. Our current city rollout efficiency is much higher than before, so by December, we're going to expand the rollout scale to cover 50 cities, including Yangtze River Delta, Pearl River Delta, Beijing, Tianjin, Hebei, and some core areas in central and western China. And we're going to ultimately cover all cities. And this is something that we're very confident about and will be committed to do. And we're going to be the first automaker in China to do it. And we deliver. Now, I would also like to give you a surprise here. Tonight, our first batch of 20 smart driving cities without reliance of HD maps will be launched for a public beta test. And also, it will be open to all users by the end of November. And at the same time, our first batch of beta users of AI driving will also start to be pushed tonight for beta test. At the same time, one thing that makes me very proud is that now a lot of the companies in the industry will launch 2 sets of smart assisted driving systems with completely different architectures and are developed even by different teams. And we used to have that in our Pro versions and Max versions. But our Pro version users will soon see that we're going to actually apply or transplant our Max version's architecture into the current Pro hardware system to achieve 2 sets of capabilities in one architecture. So they're going to be synchronized in terms of the capability, including improved SR capabilities and highway NGP capabilities. We also aim to improve LCC and ACC. And users of all subsequent Pro versions, including G6, G9, and P7i, will all expect the same sort of synchronization, and the beta testing will also start from tonight. So I actually set a new goal for our autonomous driving team, which is that they need to get prepared on global highway NGP, LCC, and ACC functions at the same time, because we're going to do globalization on one set of architectural codes. Our goal is to have XNGP fully available by the road networks in all major cities across the country by 2024. And also, by the end of 2024, NGP will also cover some part of Europe, allowing more global users to see China's leading smart driving technology. Now, I've reported XPENG's industry-leading smart assisted driving capabilities. Now, let me talk about the smart cockpit, which is our 5th-gen smart driving system, XOS Tianji. And you can expect to see it very soon. We are bringing you a completely new Xiaopi or voice assistant, and this XOS will be equipped with the Qualcomm Snapdragon 8295 chip for the first time. The boot speed will be increased by 20%, the response will be increased by 50%, and also 50% of performance improvement as well. In addition, any XOS system will work like a smartphone with the split-screen multitasking, allowing the driver and passengers to operate independently without interfering with each other. We have also made an X dock, a desktop-like dock, it can be defined like a PC desktop. It can be customized according to the needs. And for the first time in the XOS, we integrate human driving and smart driving capabilities to form an all-knowing perspective that is online all the time. Our voice assistant will also be connected to our self-developed XGPT Lingxi large model, which has a lot more capabilities. It also can think proactively and can be controlled remotely by mobile phones. At the same time, with the emergence of our XOS, Chinese car users can use the English version, and global car users can also use the Chinese version. And also, for the first time, our Chinese and global systems will be coupled together in the XOS system. and will be promoted globally. The XOS Tianji smart cockpit system will be first launched on our X9 model, and it will be installed on all new cars that we develop in the future. Meanwhile, the G6, G9, and P7i models will gradually upgraded to the XOS Tianji system through OTA. Now, AIGC has been particularly popular this year. I would like to share with you some of our applications of AIGC. We have started applying it across the board in our R&D. Right now, the entire code efficiency has increased by 15%. And in terms of our design efficiency, we have been able to shorten the days from 23 days to produce the same kind of car rendering within 6 days. Meanwhile, as you have just heard, we're going to add the AIGC capability in smart driving in XNet 2.0 and also in our XGPT Lingxi system. This will be added to our smart voice assistant as well. So we look forward to bringing these interesting features to everyone in the future very soon. When it comes to smartification or smart driving in general, the whole industry must not bypass the EEA architecture. The first generation of EEA architecture is typically distributed, and the majority of current car companies are doing this. The second generation of smart EEA architecture has independent cockpit and driving domains and is currently used by a small number of companies. And the third generation is one that is currently used by our company. We integrate multiple boards into one to achieve the integration of cockpit domain and the smart driving domain. And we're developing actually the fourth generation in-house, which integrates all smart systems into something that we call one box, one board to achieve a deeper integration. And the cost will be reduced by 40% and performance to be improved by 50%. And the next generation of our architecture will definitely support greater performance. I recently went to Germany, and I drove an electric car at a speed of about 220 kilometers per hour. I discovered something that I have not seen in China, which is the power consumption. It was extremely high at such a high speed, and the power drops out very quickly. Because in China, the speed limit is 120 kilometers per hour. If you reach 220, it will definitely not double the power consumption, but far more than that. So we recently have been discussing how to improve the energy consumption at high speeds. So the next generation electric drive system that we've been developing is that we will re-examine how to reduce energy consumption, how to reduce the use of silicon carbide, and the key cost to be dropped by 50%, which will be a key factor that we use in the future. Over time, our next-gen motor system will be designed in such a manner. Now, in addition to that, I would also like to talk about our integrated die casting technology. To introduce a brand new technical concept, we, right now, so far as we know, is the only mass-produced car maker today that are able to use this technology. It integrates both the front lower body and the rear lower body. The reason that the driving range of G6 is so solid and the cost can be controlled is because the next generation CIB and the front and rear integrated die casting that we're developing have been incorporated. And we believe that the driving range of the whole vehicle will be increased by over 5%. It's already very feasible, and we're working hard to reduce manufacturing costs by 10 to 30%. And it's very, very feasible, and we're working hard to reduce manufacturing costs by 10 to 30% as well. And if that technology is successfully researched, it will greatly improve the manufacturing capabilities of the whole industry. What kind of company are we? We're not only an automaking company, but we're also an AI-enabled manufacturing company. We are AI-driven, and AI empowers the entire technology system. We use AI to drive the growth of smart features, and we empower the entire technology system. And we continue to enhance the R&D and manufacturing capabilities within the system. We expect to expand the whole industry in the coming 5 to 10 years. In an era where the industry will undergo tremendous changes, we must lead in this era and continue to maintain our innovation capability and our leadership. The technological revolution of AI will definitely lead to huge changes in society, and we're confident that XPENG, with our commitment and dedication of our dream of the past 9 years, will persist in changing mobility and changing the world. But please stay seated. We haven't finished yet, because I have another announcement to make, which is the unveiling or debut of our new X9. Let's take a look. Have you ever seen such a flexible MPV? Let me just briefly introduce the features of X9 today. First of all, let's talk about the appearance. Now, I've tried many MPVs and I've driven them. Basically, I don't enjoy driving them. First of all, when you're driving an MPV, you are usually regarded as a professional or hired driver. You're working for someone else. Second, many MPVs are too bulky to drive. They're not a fun experience to drive. So our MPV must not be made like the previous ones. It's not a square box with a cut in the front or in the back, because it's right now the industry standard. We are committed to build the most beautiful MPV. This is basically our #1 principle. So you can see our front and rear. They are definitely very, very unique. At the same time, our X9 is our flagship model that continued to inherit our Fuyao architecture, and it's also the first model to be equipped with the XOS Tianji smart cockpit system, and it will also be the only standard configuration in the world that actually is equipped with rear-wheel steering. This MPV is as long as 5.3 meters, but you can see it is unbelievably flexible in such a small and narrow area on the stage. Think about it. When driving an MPV on the road, it's always very cumbersome to drive a big car like that. But when you use our MPV, the turning and parking is very, very flexible. And also, it's large and spacious. and it's very easy and fun to drive. And we look forward to seeing you at the debut of X9 at the Guangzhou Auto Show. Thank you, everyone.